so excited today to bring you this interview with Dr. Wafik El-Deiry. He is a legend in the world of cancer and cancer research. He is an oncologist, the Associate Dean of the Warren Alpert Medical School at Brown University, and he is a top candidate for NCI Director, which we will discuss today. His discovery on P53's role, also known as the guardian of the genome, has revolutionized what we know about cancer. His recent paper linking the spike protein in both COVID and the COVID vaccine to cancer has caused quite a stir through the international scientific community, and we will get into a deep discussion about that. I know you're going to want to hear it. We also discuss the explosion of cancer in young people, the rise in colon cancer in young and healthy people, and what his vision is for the future of cancer research if he becomes the NCI director. You won't want to miss this episode. Thank you for watching, and don't forget to subscribe. So you are renowned for many, many things, but your discoveries of the P53 tumor suppressor role in stopping cancer and the WAF1 gene, which was named after you, which is like, how many people can say that in this world, which supports P53's protective function. Can you please explain in lay terms what these two discoveries mean?
Yeah, so P53 is a major so-called tumor suppressor gene that we all have. I may be a little bit biased, but I think it's the most important tumor suppressor gene. And the published literature has well over 100,000 papers published on P53. For years, people were curious, how does this work? How does this gene we all have suppress cancer? And I came into the field around 1991. Mm-hmm. And so at that point, P53 was known for some years. I was very fortunate to work in the Vogelstein lab at Johns Hopkins. And he and his lab had just published some amazing breakthroughs on P53 by 1989. Because for 10 years, people actually thought P53 was a cancer-causing gene.
Really?
And yeah, because they were all studying the mutated version of it.
I see. Interesting.
From cancer. It's actually the most commonly mutated gene in human cancer across cancer types. And once Dr. Vogelstein's lab recognized that P53 is mutated in cancer and that the normal copy suppresses growth of cancer cells, there was great interest. Well, how does it do that? And so I was tasked with figuring out what it recognizes in the human genome, what it binds to, and what genes it turns on. And I figured those things out. Back in those days, it was recognized P53 responds to stress, radiation, chemotherapy, all other kinds of stress in our cells. And the idea was that it caused cells to stop dividing so they can repair whatever damage and go on without turning into a cancer. And so that discovery of this P21 WAF1 gene for the first time showed how these cells divide in terms of a molecular mechanism when they're exposed to DNA damaging agents and other types of stress, at the highest detail of mechanism. I got to tell you, it was a big discovery and I lived through it. And as far as the name, back in the early 90s, nobody cared what you called a gene because nobody thought it would be important. I'd present my results at lab meeting and I had a bunch of WAFs. WAF1, I had, WAF2, up to WAF10. But WAF1 kept me busy, and it turned out to be important in terms of what it does in cell division. And for many years, I thought this is gonna be the most important thing I would ever do in my life, which was, probably depressing. But
Is it true? Sounds like.
no, it didn't turn out to be true because when I started my own lab in the mid 90s at the University of Pennsylvania, I wanted to discover other genes that P53 can turn on in our cells. And as a medical oncologist who takes care of patients, I wanted to discover genes turned on by P53 that kill cells. And so we discovered a death receptor. And I never knew what that was, what that meant. But basically, it's a protein that triggers cell death when it's turned on. And interestingly, our natural killer cells use this death receptor that's induced when cells are exposed to radiation when P53 is activated. And so this helps our immune system to eliminate tumor cells when patients are treated with chemotherapy or radiation. And as time went by, I sort of became really interested in this innate immune system, but I wanted to find a drug to turn it up. And so we discovered a small molecule that ended up going to clinical trials. It's gone by several names: TIC10, ONC201, dordaviprone. And when it went to clinical trials, it was found to shrink brain cancer in people with a specific mutation. These middle of the brain aggressive tumors, you can't operate on them. They respond poorly and they, kill people.
Are they glioblastomas or are they different kinds of cancers?
They are known as diffuse gliomas, so they are glioblastomas. This drug has activity or controls the further growth of these tumors in the majority of patients. That is an amazing thing to live through because I didn't wake up one day thinking, let me do that. Having impact on patients is, there's nothing like that. And, I'm a practicing oncologist. And if you can help a patient in any way have a better quality of life or live longer, nothing comes close to that.
So that leads me to asking you about your career as an oncologist. I know you take care of patients with colon cancer. And I have been reading a lot about the rise in colon cancer, especially in young people. I recently saw an interview with Dr. Pat Soon-Chung, who I'm sure you know pretty well, where he was reporting seeing kids as young as 8 with colon tumors. He saw also a child who died from pancreatic cancer, like a very young child. What do you make of this rise in colon cancer? Why are we seeing this?
There is a rise in colon cancer and there's a rise in other cancers. In the case of colon cancer, the rise goes among younger people. It goes back at least 2 decades.
Yeah.
It's been slowly rising. Early in the COVID epidemic, it was predicted that we're going to see more cancer across tumor types because people are missing their screening and cancer wasn't being detected early when it's more curable. But there has been intense interest in the question of younger people developing cancer and a lot of ideas. But I got to tell you, I try to keep up with this literature. Nobody really knows. Okay. I mean, there are a number of factors, like obesity, the diet, and the microbiome has been implicated.
How about chemicals, pesticides, glyphosate, those kinds of things? I had a close friend who is a breast oncologist who has been telling me about this for years, that he was concerned about all the chemicals. I mean, because he was seeing it also, like he was feeling it was contributing to breast cancer too.
Yeah, I mean, so I head up the cancer center at Brown, and Rhode Island has high cancer rates across the board. And it's complicated. If you go around the state, different areas have higher rates of specific cancers. And whenever you see that, you certainly wonder about different types of exposures.
Yeah.
And there are many different kinds, forever chemicals, radon, industrial waste. It's complicated. Like, I think it's important to unravel the causes of cancer and to deal with them.
Yeah.
And I got to tell you, just a few days ago, maybe it was last week, I read a report that really disturbed me, which is that the EPA was shutting down its research.
I saw that.
And like, why? Why would why would you do that? It doesn't make a lot of sense to me, because we need the EPA to look into industrial waste and to understand the mechanisms and its impact on human health across the board. For us here in Rhode Island and in many other states, where there have been chemical spills and so on, it is important to look into the causes so we can, over time, reduce the risks. I'm a believer in science and in getting to the truth about cancer causes, whatever they may be. I keep an open mind. I know what evidence looks like, good evidence.
Yeah. Totally appreciate that. Are there things that you want people to know that they should pay attention to? Symptoms that they shouldn't ignore? I'm sure you see people when it's sort of further down the line. What were the early symptoms that they may have ignored, especially young people?
Yeah, so you bring up a really good point, and sadly, young people are often reporting their symptoms and they get dismissed.
No.
They're not taken seriously.
Mm.
But certainly, blood in the stool is something to be concerned about. Losing weight, change in bowel habits, or sort of the consistency or how thin the stool is, are things to look out for. I would say one of the things with colon cancer in younger people is this actually happens with certain inherited mutations. So some people get colon cancer early in life, and the reasons there are known. There's familial polyposis with a specific gene mutation, and we have Lynch syndrome with non-polyposis colon cancer. The genes are known, and when it runs in the family, there are certain things you have to do early in life to avoid developing a cancer. And combination of screening and actually, in polyposis, they have their colon removed while they're teenagers.
Oh, I didn't know.
Because if they don't, 100% will develop colon cancer.
Mm.
Now, there are a bunch of different tests for colon cancer. I would say, whenever I speak, I tell people about the guidelines. I urge people to get their colonoscopies. The American Cancer Society a few years ago lowered the age to 45, and other guidelines followed after that. And so, if you're approaching 45, you should schedule your colonoscopy. If you have any family members who have cancer, talk to your doctor about it, and they may refer you to a specialist, because there are guidelines for getting colonoscopy earlier. But I think we need more awareness that colon cancer is occurring in younger individuals for reasons that are not very clear. And so don't ignore the symptoms. And, there should be some explanation ultimately for what is going on. I mean, like you, I read many stories of people having symptoms, and then the cancer is discovered pretty late.
No.
And
Yeah.
at that point, it's really hard to treat. I don't know what to make of some of what Dr. Soon Shong describes with very young people, young children who are getting colon cancer. I'm troubled by that. I have noticed over the last probably 3 or 4 years, a lot of examples on social media of cancers, and some have concerns about, does this have anything to do with the pandemic or
Yeah.
vaccines or this or
There was a
that?
great article in Washington Post that said a bunch of oncologists, I'm sure you read it, maybe last year, that just talked about this alarming explosion of rare cancers, bile duct cancer, appendix, cancer of the appendix, things that people like you were not seeing typically. And it is, they did attribute it to COVID. They were saying like since COVID. I don't know if they're thinking that it's the virus specifically, but it seems like there are signs that the virus could be oncogenic. I want your opinion on that, though.
Yeah, I mean, so I have things to say about that because viruses can and do cause cancer. There are a number of very well-known examples, human papillomavirus causing cervical cancer and head and neck cancer, hepatitis, B and C causing liver cancer, and a number of other examples. There's a virus that causes a kind of sarcoma in patients with AIDS and a suppressed immune system, and on and on. So, and then there are some ones that are controversial about, they've been implicated, but they continue to be controversial year after year.
When you say that, you mean certain infections that are implicated in cancer? Okay.
Yeah, I mean, there's one, SV40 is an example.
Uh-huh.
And it's some have suggested maybe links to mesothelioma, they're still out there. I mean, there's an interesting history that goes back with people testifying before Congress decades ago about specific data. And over the years, there's no doubt that SV40 can proteins made by SV40, which is a monkey kidney virus, will transform human cells. And so there's, some circumstantial evidence. So when the COVID pandemic started, well, I should say this, we learned a lot about cancer by asking questions. How do viruses cause cancer? So there's a whole field of tumor virology out there. And interestingly, as an expert on P53, tumor-causing viruses often attack P53, which is part of how we protect ourselves from cancer. They attack P53 and another gene called RB, and very important discoveries over many years. So when the pandemic started, I became interested in, proteins that the virus makes, and could any of those proteins affect P53 in any way? As an expert on P53, we can interrogate that. So when COVID started, we saw this phenomenon around universities around the country of research is not essential. We can shut down the labs and we got to deal with the pandemic. And that really didn't sit well with me. I felt like research is very essential. And we knew something about this immune system we were talking about. And a lot of cancer drugs have effects on things in cells. So some of our early work during COVID involved things like we discovered a class of compounds used to treat cancer. They're called MEK inhibitors. It's a whole class of drugs that suppress expression of ACE2. The protein, yes. We published that early on. Another study we did here in Rhode Island was we got blood samples from patients in the emergency room looking for things that would predict severity of infection, things you could measure when they showed up in the emergency room that might predict admission to the intensive care unit or intubation. And we recognize, I learned about something called macrophage activation syndrome. I'd never heard of it, but, there was that signature in the patient blood samples that correlated with severity.
Yeah.
Those were our early observations. And Initially, I was sort of excited about these MEK inhibitors. Could we attenuate the way the virus infects human cells?
Yeah, that was my
I
question.
think it can, we had evidence that it could do that. But that largely went by the wayside once there was a vaccine. So, we were doing this type of research in 2020, but by the end of 2020, there was a vaccine. And so, some
Wouldn't
of
it have
those.
been better though to also have that? To me, that makes a lot of sense.
Yeah, I mean, I would say the mindset when these vaccines came out, I gladly took the first shot. It was required, but there was fear, and I was glad because the idea that it could reduce severity, I bought into that. And certainly we saw people dying of COVID. You just watch the news all day. And so if a vaccine reduces severity, that's good. And the other stuff, you'd have to do clinical trials to show it works and so on and so forth. And I certainly approached companies. I approached Gilead back then with this data, because I think some of our data showed that remdesivir upregulates ACE2, and we had a way to suppress it. And wouldn't you want to do that? And
Can you explain that just for the layperson who that's an important fact about remdesivir?
one of the things, whenever I talk about our research, is to make sure people understand the limitations.
Yeah.
Okay, so I will say upfront, all these experiments did not involve human tissues from patients who were exposed to COVID, remdesivir, or these MEK inhibitors. But we looked in human cells.
Yeah.
And in human cells, patients were getting remdesivir, and we noticed some upregulation of ACE2, which was notable. What would that do? And we were interested in suppressing that because we had the knowledge. We could look at this receptor the virus uses, and we could study what makes it go up, what makes it go down, and could we get at that somehow? And I think, once the vaccines started rolling out, there was just lack of interest in pursuing these things. I mean, we had a little bit of money and could do some experiments, but to go further, we needed support and collaboration, and there just wasn't the interest. So fast forward, we had initially proposed, and we were really grateful to Brown University for awarding us a grant to do some COVID research. And so the experiments I described were part of that. We had also proposed some experiments to look at the effects of spike, which is a protein, the virus uses to infect cells, and it gets into the cells.
Yeah.
What could it do? It seemed like a candidate we could study. We could buy reagents and express the spike in human cells and look at the effects on P53. And we had the expertise to interrogate those effects on P53. So eventually we got around to doing some experiments. The results suggested that if you express the spike protein in human cells, and we use human tumor cells because they grow easily in the lab, and we could do these experiments, and some human tumor cells still have wild type P53, which means it's not mutated. And we were able to demonstrate that the spike attenuates the activity of P53. So
the spike, so just for, again, to break it down for, like, my mom's going to be watching this, right? So that means that the spike, it promotes cancer. Is that kind of what?
Yeah. So the data shows in a setting where that spike protein gets into a cell, if that cell is triggered to activate the P53 response,
Yeah.
so for example, by chemotherapy, and we did those experiments, when the spike is expressed, the ability of p53 to activate those genes that we've discovered decades ago was reduced. To me, that was clear evidence of a molecular interaction between the spike protein and the p53 protein in terms of function. But we took it further, and we asked a question, and we looked at this in different ways. Technically, we looked using reporter genes, and then we looked at the actual proteins that p53 normally induces in cells when it's triggered, and they were attenuated. And we also looked at, well, what could the consequence of this be with regard to the sensitivity of these tumor cells to the very chemotherapy agents they were being exposed to? And we observed reduced sensitivity. There were some other findings in the paper. With that type of data, one would look into this more at a minimum. And, we discussed this in the paper that was published about a year ago. As a scientist, as an oncologist, I'll tell you that, and then I'll get to your question. I wanted to look at what can we learn from what we just observed?
Yeah.
Because I look at p53 as controlling a host response that keeps us healthy, keeps us from developing cancer. And here, when we express the spike protein, whether it's coming from infection or a vaccine, it seemed to interact with the function of p53 and attenuate it. So what could we learn from that? Well, in my mind, what I came away with was, could we use that information when we develop vaccines so that we optimize the boosting of the immune system to fight the virus, but could we minimize any collateral damage?
Yeah.
Could we learn from that experience? Is this feasible? Is it doable? Absolutely. And so, we discussed that. Now, with respect to the cancer question, well, first of all, I alluded to certain viruses and their association with cancer that can be implicated, but that can remain controversial for decades sometimes. Under some conditions, maybe you can show an effect, but then the question is, did this virus actually cause the cancer in a human that developed a certain kind of cancer? And of course, to get at that, one needs to have data. Data includes epidemiologic data, which sadly, I don't think we have good epidemiologic data. There's a lot of information out there, but I still have not seen a source that looks at vaccinated versus unvaccinated, COVID infected versus not, with long-term follow-up. You don't look at cancer endpoints at 42 days. You
Right.
got to look further. So there isn't that data. Personally, I have no idea why. 5 years later, why don't we have that data? But then there's more. We've read reports about the spike protein traveling and disseminating. I mean, one of the interesting things with the mRNA vaccines, it won the Nobel Prize. Normally RNA, if you breathe on it, it degrades and goes away. The Nobel Prize winning discovery was if you substitute pseudouridine in the RNA, it becomes stable.
Right.
And, Jay Bhattacharya last year, when he was still at Stanford, made some comments that I found very interesting. He articulated that when you inject this mRNA vaccine in humans, we don't really control the dose of the product that the injection makes. We don't control the biodistribution or ultimately what happens within the human body. And I think that those are very important points. And how does science get at this? Science gets at this with evidence, okay? whether it's from postmortem examinations or biopsies or different tests that one would do. I mean, to be honest with you, I like the data to speak for itself. I know what valid, well-designed studies look like. I know what convincing evidence looks like. And, we should have the evidence and we should be able to make conclusions that are just supported by that evidence. And I would just love to see more of that. What I have seen is lack of progress, I would say, in those directions. In a way, when you look at the anecdotal reports on social media, I think some of this is happening slowly. It's coming out. But I think, for the community to believe, whatever your point of view may be, it's going to take good epidemiologic data and good forensic evidence of what goes on in the body after infection in different tissues. I think there's plenty that's known at this point about the virus and its effects, in the brain, in the heart, in the ovaries and so on. And I think the vaccines are similar in that regard. And so there are ways to get at this.
Are there genetic markers? So if you're biopsying a tumor where we could tell this spike is derived from the virus versus the vaccine or the vaccine versus the virus?
So the spike itself may be very similar, but it gets more complicated with different strains and what was vaccinated against exactly. But the vaccines produce spike. They don't produce nucleocapsid protein, which, the viruses make other proteins. And so if you weren't infected, you're not going to find those proteins. But it has to be controlled because the timing and the source of the tissue matters if you really want to get at this. I mean, I was impressed by some reports that showed growth of sarcomas in the arm.
I was going to bring that up. I know somebody who had that, actually, a young woman.
Yeah, I mean, how does that happen? I mean, you're injecting there, and please explain how that happens. And I think the blood circulates, the immune cells circulate where injections are given. And so, some lymphomas occurred. But these are anecdotes and sort of in some people's mind, these are the lowest levels of evidence. But you got to start somewhere. I mean, if you're seeing these things and if people are out there saying there's all this cancer, I want to see some good data. Why can't we get some good data, good epidemiologic data and good studies in these specific cases? What's happening to spike? If the patients don't make it, I would urge people to think about doing those autopsies to help mankind.
Yeah.
By looking at the tissues and trying to understand the causes. I mean, there are other markers that one looks for in tissues to try and understand relationships and mechanisms and, did this cause that? But it's not just the human tissues, it's additional experiments to get at causality are feasible. I mean, that's what science can deliver on. And I just think we need more of that.
I do know people that are concerned, like you are, and say they can't do these experiments because they will be targeted. So, and I was going to ask you this later, but, you've been in the line of fire for your work, talking about the spike and the suggestion that it could be from the virus, could be from the vaccine as well. A lot of people agree with you, but then there's been all these trolls coming at you, this whole mob of people.
I think it's unnecessary to attack people and their character and their credibility and to try and cancel them and ruin their reputations. We're seeing that as a phenomenon. I mean, why not have a civil discourse with facts?
Of course.
Results to actually debate things in the tradition of science rather than resort to that sort of thing. And, once that happens, I mean, I think people dig in and they become a little irrational at some level, and we could all do without that. I did this experiment and I wrote a little article in Substack, maybe it was last week, because I found myself having a conversation with Grok.
I saw it and I read that was a fabulous Substack about AI, and I was going to ask you about that.
Well, I'll tell you this.
Hmm.
Having that conversation with Grok was more fun than having conversations with people who are just attacking.
I think there's a lot of people that will watch this that don't really know what goes on social media and don't know about these attacks. Do you feel that they are, I mean, to me, these seem very concerted and coordinated, and I've seen them happen to many people in the research community throughout different topics, not just like gain of function, bioengineering pathogens, and there's been all kinds of these coordinated attacks. Do you think that for you, is it like pharma trolls? I heard from a scientist I spoke to last night who said there are a bunch of failed scientists who have nothing better to do.
I think some of them are not scientists, and for the most part, I don't think they are truly my peers,
No.
regardless of what they say. And they're definitely concerted attacks. I mean, I started noticing these attacks escalating in July of last year to a point where, PubPeer was just targeting my papers going back to the mid 1990s.
And was that, do you think, related to your publishing about the spike and the possible cancer causing nature of it?
I became a target. It's circumstantial, but it is in that time frame. And by being targeted, I started to look into how they operate.
Hmm.
And they target, I would say the vast majority of these things are minor errors that could be corrected. Some are inconsequential. I mean, I was telling you about the paper where we looked at the blood of the patients with COVID.
Yeah.
They went to a supplementary table, and one of the concerns was that we misspelled the word intubation in the table to incubation.
Oh my gosh.
That triggered a whole concern about that. Now, anybody who reads the paper with who is reasonable and not out to pile on concerns would recognize that's a typographical
Of
error.
course.
Read the paper and don't waste everybody's time. Now, when you go back to the mid 90s, the damage isn't just that they express their concerns publicly, they go further. They contact the NIH, the government, they contact employers, and they contact journals, and they contact with allegations of fraud and misconduct. And guess what happens then? All of these institutions are obligated to investigate. And so here we are dealing with issues going back 30 years. Many things have changed in 30 years.
Yeah.
What was acceptable is different, number one. Number two, in 30 years, if there was a concern about some validity of anything in a paper, it would have been pointed out by people and would have been addressed. But so there's no statute of limitations, which I think is outrageous. Number two, there's no attention to the significance of any concern. You look at the concern, and we've addressed concerns, we've made some corrections. First of all, I'll say there has never been fraud or misconduct. And I've worked with hundreds of people over many, many years. Our work is very well known in the field, and I will stand by everything we've ever published. So there's no statute of limitations. They're largely not our peers, and they have methods that are being exposed. There's this entity out there called Science Guardians that is slowly exposing them because there's a small group of people who work together and they use aliases
Yeah.
and they create fake accounts to support each other.
I,
And they have different platforms that, bounce off of each other. Um, for me, I mentioned our research and our accomplishments, and we all have a certain limited amount of time every day and on this earth. And I would like to spend my time doing good to help patients and help mankind. And what this has done is waste my time.
yeah.
And for me, that is damage. And it's not just for me. It's for other hardworking scientists who are innocent, who are accused and get investigated. I just think that our profession needs to look at this. I think our government, I think Homeland Security, the FBI, they all need to look at this and do something about it because it's not about me. It's not to diminish the importance of errors that need to be corrected and the importance of dealing with fraud.
No, this is something totally separate. These are coordinated personal attacks to try to discredit certain researchers who are doing work that they don't want to be promoted. I mean, coming after somebody like you is like ridiculous. And you've been such a gentleman. Yeah, I've watched some of these exchanges unfold and other people watch it and say, oh my God, you're a prince. You conduct yourself like to this high level of integrity, and they are just wasting your time and spinning your wheels. And it really enrages me to watch it. I was wondering, some researchers are suggesting that the COVID vaccines could increase cancer risk through other mechanisms like plasmid DNA contamination, spike persistence, which we talked about, or immune changes, IgG4 shifts, even SV40. So, and also lipid nanoparticles. So I hear all these things, and I wondered your take on some of these other mechanisms proposed as potential cancer causing.
I keep an open mind. I think the mechanisms are plausible. I mean, people have been pretty dismissive of the DNA fragments, the potential persistence of plasmid DNA that could replicate and get into the genome. We have the tools to get at the truth. We have the tools to look at these things and have evidence speak for itself. Lots of people are saying things, and the mechanisms are plausible, and some are in the end going to be more important than others. Integration events in the human genome are well known, with gene therapy to cause cancer.
Right.
That's known, if you get inserted in somewhere and turn on an oncogene, you can get cancer. This is known with gene therapy that has decades of knowledge and experience.
Right.
The lipid nanoparticles, I mean, people say, well, these fragments or these plasma, they don't get into the cells, they don't get into the nucleus, whatever. I mean, the lipid nanoparticles take them there.
Exactly.
They bring them there. And I've certainly heard about lot-to-lot variation in the extent of this type of contamination. I mean, I think personally that the public is entitled to knowing what went on, and if things need to be cleaned up, they need to be cleaned up. I mean, I think we're watching the administration and RFK come up with, vaccine injury claims and trying to help people that way. And that's probably long overdue. I mean, sadly, money and greed and so on impacts on some things that we happen. And I think it's up to the government and regulators to crack down on what happens and to use the highest standards to keep us all safe.
Do you have patients that have come to you and said, Dr. El-Deiry, I feel like this came on after I got the virus or after I got my booster or whatever? I mean, I hear these things, somewhat regularly, and I wondered if you hear them in real life and as a doctor.
Yeah, so someone approached me, and she herself was a physician,
Mhm.
In the New York area, and I'm in Rhode Island. And she had ideas about her condition. I don't think in the end the mechanisms were understood. I think in the face of concerns, the anecdotes are just not going to do it. I mean, and but I think there's enough noise out there. Why do we keep hearing more and more about these things and what's going on in Japan? We're hearing things going on there. And, why can't we have our own data and settle some things with good quality data? That's how we convince people. Reasonable people, whatever they believe or want to believe, always appreciate rigorous study design and data that are controlled and support a conclusion. And I think some of what's happening has cut corners. And I understand that, in a public health emergency, but I think that over time, we can't be cutting those corners. I've had debates online about, I bet as it was accused I'm an anti-vaxxer. I'm not an anti-vaxxer. They prompted me to say, we're all different. Some of us may be more susceptible to certain
To
certain adverse outcomes. Okay, we're
sure,
not all the same.
right.
Okay. Some of us have, and these things are subtle, even from the point of view of cancer, how our cells repair varies across the population. Some of us may be more susceptible. My position has always been, okay, yeah, I think that's the case. And for me, informed consent is knowing what those risks are. Is it one in 10,000, one in 100,000, one in a million? What is the number? And I think that's what informed consent is. Don't argue and tell me this is irrelevant or whatever. There is a number, there is a risk. What is the risk? I've got to use common sense, but with data. And that's what we need. That's what we need more of. And I do believe certain things should be settled one way or the other definitively with good quality data. I mean, but you have to ask the right questions to understand more what is going on. If there are connections, if there's a smoking gun, these things usually aren't subtle.
Mhm.
If you look at the tumor tissues and the evidence is there, why don't we have more of that evidence? And why isn't that evidence, whether it's positive or negative, being published in the top journals?
That's the million-dollar question.
Yeah, so I hope that the government supports that direction. And I hope that my colleagues and peers look at that evidence and keep an open mind. The truth will be the truth 50 or 100 years from now. It's
Right.
not going to change, whatever it is. If there's censorship or lack of diligence or whatever politics, I mean, we don't need any of that in science. We just need to get at the truth. And if we don't do it, it's going to come out in the future, and we're going to, this period is not going to look so good. So why don't we get at some answers?
Yeah. Given that cancers can be infectious, and we talked a little bit about that earlier, I've read a lot about antimicrobials being used in cancer, or that some people think they should be used, things like antiparasitics like fenbendazole and ivermectin, even doxycycline, which is an antibiotic, as you know. Is there a role for these drugs in certain cancers? And could they enhance even chemotherapies?
It's a good question, and I will handle it in general. So there's certainly evidence out there about mebendazole. I have a colleague at Johns Hopkins who studied it in brain cancer. I mean, things like ivermectin, will modulate the immune system. Things that modulate the immune system can potentially impact on outcomes. There's a lot known about the microbiome and how that impacts the immune response and or contributes to cancer one way or the other. And guess what? The microbiome can be modulated with antibiotics, and plenty of people are and have been working on that. And so, I mean, I like what Dr. Bhattacharya has said about considering different points of view, different mechanisms, different questions, and doing good science, and maybe that type of science is not going to be done by big pharma, but it could be done if I mean, again, here's a case, there's plenty of anecdotes, but by the way, there are anecdotes of people who have taken ivermectin and it did not help them. So
Sure.
anybody out there, maybe it helps some people. Maybe we need to learn more about that. I don't know. I think Dr. Makis out there has treated a lot of people.
I wondered, are there cases on your radar where they have been effective at curing a cancer?
I know of no patient. I have written to Dr. Makis. Actually, no, I think I posted on social media, Dr. Makis, it would help the world to publish your experience with these drugs so that everybody can look at it. And maybe he's already doing that. But I think, if somebody claims to have treated more people than probably anybody on the planet and espouses these treatments, share the data, show the data.
Yeah.
Anecdotes, I mean, it's just the mindset out there. What are the numbers? What are the examples? Show some scans, give us a sense of and for me, I'm open-minded. But often patients also are doing many, many other things.
I do want to send you one case. She had kidney cancer and she took she was a researcher and she wrote a brilliant book. And I'll offline send you a little bit of info if you're interested in reading some of her emails to me. But she cured her kidney cancer, she says, and she claims, and she will talk about the evidence in these emails, with doxycycline, high doses of doxy. And it was fascinating. And we're in a little chat group with some physicians, and they all thought this was an incredible one-off case. But
well, I'll tell you this, as a colon cancer specialist, we use doxycycline to help with certain types of rash that, get infected in the skin, to keep that under control. I mean, there's got to be epidemiologic data with that.
Yeah.
So there's plenty of experience with doxycycline, and I would not discount the impact of the microbiome and its connections to cancer. It's very well documented. Certain bugs cause cancer. People have found bugs in metastases in people. And, it's an area about which we need to learn more, and exactly how these drugs ultimately are incorporated. There are plenty of alternative medicines and other approaches to treat cancer, and that should be part of our portfolio of anything and everything that would help, and how much does it help? What is the data support doing?
do you think that with, COVID they've found it persisted in the gut for like 200 days or more? I think Michael Peluso did that study. Do you have concerns about that specifically related to COVID?
I think it's interesting that it persists. And whenever you have persistence like that, there could be connections to different types of diseases in that population. What are the consequences? The tools are there to look at consequences, whether they're molecular or physiological.
Yeah.
And I think we need more good science to look at those consequences in the gut and elsewhere in the body.
Yeah.
I mean, I was learning about things that happen in the brain because recently there was like an outbreak in New England and at some hospital with a bunch of different types of brain cancers. And
I read about
yeah, so I mean, the virus does have these effects. And in fact, I think that early on, one of the manifestations involved the GI tract. It wasn't all lung.
Right. It's so crazy that we thought of this as a respiratory virus, and actually, no, it's not just a respiratory virus. It's living in the gut, it's living in all these tissues all over the body.
And I think, one of the things, I mean, early on that I couldn't really understand very well is why some people are more affected by this than that. But
Right.
I think those are good questions.
What about the future of mRNA and cancer?
I am definitely watching this with interest. So earlier this year, there were a couple of papers looking at vaccines. One used the peptide vaccine approach in kidney cancer and had some promising results, and the other used an mRNA vaccine strategy in pancreatic cancer with promising results. I think patients with cancer typically have a limited life expectancy. And so I think it's reasonable to look at promising technologies and understand how well they work
Mm.
and what the downside, what the risks are. And, there's nothing that's completely safe. Most therapies have side effects. And so I think there has to be a balance. There are probably ways, and I'm sure plenty of people are thinking about this. How do you make them safer?
Right.
What would be required if there's any concern about, the RNA being made into DNA and getting into the genome, or the control of that expression of whatever they're expressing? How long does it last? Can you develop a kill switch,
Yeah.
which is something, that people did with gene therapy. I would be the last person to put put the brakes on anything that ultimately could prolong life and help people in some way. But I do think we have to be well informed about the potential downside.
Your PSA, what are your recommendations for preventing bad outcomes with colon cancer?
With colon cancer, screening is recommended. I will say this. Polyps are common, and when they're smaller, they're less likely to have cancer in them.
Hmm.
The bigger they are, a 2 centimeter polyp or a 1 to 2 centimeter polyp has a 5 to 10% chance of having a cancer in it. So basically, the bigger they get, the more chance that they have cancer. And if they get much bigger, that cancer starts to grow into the polyp and can
Right.
invade. But a cancer in a polyp can be cured just by the colonoscopy.
Just by the colonoscopy. If you have a clean colonoscopy, zero polyps, what would your recommendation be for somebody in their 40s or 50s in terms of a follow-up? Is it 10 years? Is it 5?
Typically, colonoscopies, if they're clean, are done every 10 years. Okay. And then, when you get much older, 75 and beyond, the risks go up and you sort of have to weigh those risks. And some people would only do a colonoscopy if you're having symptoms,
Yeah.
as opposed to let's just do another screening colonoscopy much later in life. I will say we now have blood tests, for early detection. We have multiple cancer early detection blood tests. We have blood tests that will detect colon cancer specifically early. Some people will get them because they're not so expensive, and having information often is better than having no information, as long as you understand the limitations. That a negative test doesn't mean you don't have an early cancer, or that a positive test will translate into definite cancer. And this could involve having more tests that cost money and, are inconvenient. So, all of this is evolving as we speak, not just for colon cancer, but across tumor types.
Let's talk about this very exciting possibility of you becoming the new NCI director. I know you are a candidate. Where does that stand? And I'm curious what your vision would be if you became the NCI director.
So I've been a candidate since December. I am concerned about some of what I'm seeing. What I stand for is patients first, truth, public trust, and attention to actual impact. So, I'm an American Cancer Society professor, and every American Cancer Society professor every year knows the cancer statistics. So despite all the advances this year, 2025, more than 2 million people will be diagnosed, more than 600,000 will die, despite everything we have accomplished. And if you do some things with diet and lifestyle, you can reduce almost half those cancers. And so ultimately, we invest in science and in research to understand the causes of cancer, to learn about new and better ways of preventing it, and to find new cures. And all of that research brings hope to patients and to the community. What's been happening in recent months is stuff we've all been reading about with reduced budgets.
Right.
And I have an outlook on that because I've seen NIH budgets for 2 decades now, and they've been flat. If you do the math with where these budgets should be in 2025, the NIH budget should be $216 billion, not $27 billion. The NCI budget should be $36 billion, not $4.5 billion. When you look at the numbers that are proposed, that's almost 10%. People who have lived through the last 20 years and suffered with low, success rates with grants and the competition, that is not a good situation. But it's much worse when you think about where we want to be. The Trump administration is about America first. How are we going to be America first if we are not supporting science and technology and cancer research? So, my position has been we have to cut waste, cut inefficiency, make sure we have a return on investment, but we also really need to pay attention to the competitiveness and to remaining and continuing to lead the world.
Right.
We spend so much on defense and
Right.
many other priorities. Yeah. This is nothing. The competition is stiff, and once you fall behind, once the drugs and the discoveries are happening elsewhere, and there's a brain drain, and people are moving to other countries, we may not recover from that.
Well, I am rooting for you, and I hope we'll find out soon. Thank you so, so much for your time, for your insights, and for your vast amount of integrity. Thanks for joining us today. Please subscribe or follow along for more really interesting conversations, and I'd love to hear from you. So please drop a comment or send me a note. Let me know what you think.